This is going to, if you write this in your console or in your script and you just run it, it's going to run the query in that particular order. So this is what I'm saying in essence. So let me go to my R. It's very easy. So I have to log to switch this. So this is my R Studio. Can you see this guy clearly, or let me actually zoom in? Let me zoom in. I think you can't. You won't be able to see it clearly. So let me zoom in. Is it better now?
Yes, it's clear.
Okay. So in essence, that's okay. I want to do A is equals to 3. And I want to say C is equals to 5. I'm now saying, sorry, I have to put a semicolon, not a comma. So I'm now say A plus B. I don't need to put a semicolon again since this is my final operation. And if I should run this guy, you are going to see it. It's going to perform this operation from left to right. First of all, it does this, then it does this, then this one finally it does this. Then you can see that the result of that A plus B is the one that is printed in here. Now, but if I should do something like this, say, and I say A plus B plus C, for example, and I end this, and I say C is equals to 10, and I run this, what do you think is going to happen if I should run this statement, this line of code? Are you with me?
I'm with you.
So what do you think is going to happen if I should run this line of code?
Okay, so because you are assigning 10 to C later, I don't think it would work in the addition. You need to assign the 10 to C before this.
Okay, yeah.
A plus B plus C.
So you are saying it's supposed to throw up an error because it doesn't know what C is
At that time, yes.
At that particular time. Okay, so let's run it. Yeah, so non-numeric argument to binary operator, blah blah blah. So it throw up an error in this guy because it doesn't know what C is at that particular time. But okay, let's see whether this guy has already run. Sure, you know. Let's see whether he's going to know C now. Let me call C. As you can see here, you didn't call up C. This is what it got. Maybe C is not a function. So it can't identify C. Okay, let's do another thing. So let's say A is 4, and I say, no, I don't want to use A again. Let me remove A. So let me remove A. Let me remove A and B. A, comma, B. Okay, so if I should call A now, it doesn't know what A is. So let me run this code again. Pop up an error because it doesn't know what C is. So let's call A. You can see it identifies A. So it means it's going to know this guy. It's performed this guy to this guy, but it didn't perform this guy due to it doesn't know this guy. So the error is only thrown up for this guy, but all of these other operations are performed successfully. That's the what I want you to get in essence. Do you understand? All right, moving forward. So good thing, I'm done with this slide, so let me move to. Are you there?
Yes, Emmanuel.
So here we have the conditional statement like if else. conditional statement. So in this case scenario, let me go to my R Studio. Oh Lord, Jesus Christ. So the if statement is that, okay, if a particular condition is met, do this. That's just ordinary the if statement. But you have if else. So if else is that if condition, do this, else do that. So in if else case now, so if the condition is met, it does the condition after the if statement. But if all other condition fails, then the else statement is being executed. So what am I trying to say in essence is that let me go to my R Studio. So I just have to go back and forth. This. Yeah. So I will say if a less than 10, I will now say I can say return hello. I'm going to use I might not use return, I can just say this, doesn't matter. So I can say I'm going to put a brace, then the brace, anything is the body is what you want it to perform, the operation you want it to perform. I can say print hello. If this condition is satisfied, then it performs this operation. So let me run this conditional statement. You can see it's actually printed hello, as you can see in my console here. Reason being is that a is actually less than 10 because other I assigned a to be what 3 here, and a is actually less than 10. That's why it's printed this this statement, because it is true. So suppose this guy, I want to make this condition to be false. Say if a greater than 10 prints hello, then if I should run this guy, it's not going to print this hello because this condition is false. So if I should run this guy now, you can see he didn't print anything. You can see in the console that he didn't print anything. So looking at the else statement now, if I should put the else statement in this case now, you know that if a greater than 10 prints hello, I will now say, okay, else. And in the body of the else, I'll say print it is not greater than 10. So if I should run this now, you can see that it's printed what? It is not greater than 10 because this condition fails. So that's why it's not printing this. Then else means after all other condition has failed, do this. If all other conditions should fail, do this. You can have several if statements in a particular if conditional statements. You can have else if. Else if is that if the first statement does not hold, check for another condition. If that condition, if that other condition does not hold, check another condition and stuff like that. That's the essence of using else if. So if condition A, do this. Else if means the first condition you have already assigned called. If it doesn't hold, check the second condition. Then you can say, okay, check again. Then you can put an else statement. Say if all other condition fails, then do this. I hope you understand what I'm saying before I proceed to what I want to type now.
Yes.
Okay, let's try an else if. Let's add else if to it. So in this case, I'll say else if. Else if. So I'll say else if, then I'll put a condition. Else if A plus B less than 10. Print this guy. So let's check. So you can see that it printed what? It is not greater than 10 because this condition holds. If I check, A plus B is what? 3 plus 5. which is 8, and 8 is actually less than 10. So that's why it's printed this particular condition. Then you can put an else statement if you like, if you so wish, that's if all other conditions should fail. So I will now say, sorry, I'll say else. Else does not need a conditional statement. So else, I will say, sorry, else print all other condition failed. So I want to make this one to fail, this second one to also fail, so that you can print the else statement. So if this, do this, else if this, do this, else, that is if these two conditions should fail, do this last guy. So let me run this guy. You can see it printed all other condition fails. I should have put condition, doesn't matter. So that's about the if statement, if else if, and all of that. I hope that is well understood. Okay. Can you please start the recording? Okay. So yeah, talking about loops. So loops is useful when you want to make a particular operation to run over a particular period of time. So we want to iterate over a particular set of values and stuff like that. So you want it to repeat for a certain number of time, and you can't actually do without loops. You can't do without loops. You can't just do without them. You can't just do without them because you have to perform some analysis whereby you have to iterate over the set of values to search for something. Just like, okay, I'm looking for a particular book in a store. I'm looking for a particular book in a store, and I only know the book by the name. I only know the book by the name. And you have several books in the store. The only way you can get that book is to start checking one by one for each book in that store until you find that particular book that has that name you have in your head. So you might not even know the name of the book like in a sequential manner. It might just be, just know there's a keyword that you are looking for that will make you to identify that this is the book you are looking for. Then you have to iterate over this. So that's where loops comes. You can say, okay, for all the books in this store, check name, where the name of the book is equal to or matches this particular pattern. Say so name. Then you have to, then the loop starts searching one by one. Check the first guy. No, it's not this guy. Check the second guy. No, until it finds that particular guy, then the loop is going to stop. In that case, you can talk about a while loop. When you need to search through all the particular set of books, then you can use a for loop. You have to loop through all the particular values in that particular set. So while loop is just, okay, while the particular condition is true. So in this case scenario, I made mention of a book. You are searching for a book with a particular name. You now say, while name not equals to this particular name, continue searching. So if I look for if I get to the first book, if the name I'm seeing on that book does not match the name I'm looking for, the search will still continue until I find the book with that particular name. Then the loop is going to break at that particular point in time. All right. So talking about the for loop, a for loop actually loops through a vector of integers, each time executing the set of commands, and takes on the general form of for counter in this for I in range. In Python, they say for I in range, this. But in R, you say for I can be a counter in a particular sequence. Say maybe 1 to 20, maybe 3 to 5, stuff like that. Then you can say, okay, do so, guy. So it might not even be for a particular sequence. It might be for a particular set of values. Say, for example, the book value. I can say, okay, for name of books in a particular store, print all the names of book I have in that store. You understand? You can do that. So for example, you can see here, it said the for loop for I in 1 to 6 is sequence 1 to 6, print I. So this for loop is going to print 1 to 6 for you in that particular order. So let me go to the next slide. This is while loop. So let me just loop for you. You can put the conditional statements inside the for loop if you are searching based on a particular condition. So for example, so I can say for I, so for then the condition is going to be in brackets. I can say for I in 1 to 10. I put a brace, then inside the brace I have the operation I wanted to perform. Print I. So if I should run this guy, this is going to print 1 to 10 for me. As you can see in the console, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I can put a condition here. I can put a condition. I can say, okay, I don't want it to just print I for me. I don't want it to just print 1 to 10 for me. Okay, I want to say, okay, for I in the sequence 1 to 10, check if I is greater than 5. If I wrote 50s. If I is greater than 5, print I. In this case, instead of it to print 1 to 10 for me, it's going to print 6 to 10 because those are the i's that are greater than 5 in the sequence 1 to 10. As you can see, it's printed 6 to 10. I can say, okay, maybe what I needed is even numbers. Even numbers. I can put a condition to check that. So I can say if I modulo, that will be percentage sign 2, same thing as 0, do this. So if I should run this guy, oh, is it double? I think it's double percentage sign. Let me check again. Yeah. So if I modulo 2 is 0, it's same thing as 0, print I. So because even numbers is divisible by 2. So I for me, as you can see, it's print even numbers between 1 and 10. I hope that's well. So that's well explained. You can also use it on. You can. It's not only on vectors. You can use it on data frames. You can use it on matrices. So, for example, let's say iris dataset. For example, let me check the head of iris. Iris. Now, so for example, if I want to say I want to print the first 5 entries or the first 6 entries in the petal.weight column. That's 1 to up to this place. The first 6 entries, I can say, okay, for I in iris ampersand petal.weight print. So I wanted to print okay, so let me just say petal.width for the first 6 values. So print I. print I. So let me run this. As you can see, this is the first 6 values, 0 0.2, 0 0.2, 0 0.2, up to what 0 0.4, which is the same thing as what the head of iris return for peta.width column. Yeah, so as you can see here. So it's not just only vector you can use the for loop with. I believe you understand what I've been talking about before I move on to the while loop.
Oui, monsieur, I understand.
Okay. So let's go to the while loop now. I've already given an intuitive description of how the while loop works. So the while loop executes a set of commands repeatedly while a condition is true and exits when the condition evaluates to false. And it takes this particular general form. While condition task. It means while this particular condition is set to be true, be performing this particular task for me. So this is how it works. First of all, while you check this condition, is this condition true? You go to this task. After it has perform this task, it comes back to this condition. Is this condition true? Then it goes back to the task again, and it will continue to execute tasks until this condition evaluates to be false. But if your condition is being set such that it soon evaluates to be false at any particular point in time, it means that this task will continue to run forever. So you should be careful if you are writing a while loop. You have to be creative. For it to come out, you can't just use while loop anyhow. You have to know exactly when to use it, because it's very, very useful. And if you don't know how to use it, you just write a loop whereby it will execute that task forever and it won't stop unless you stop it automatically or manually by yourself on maybe the R Studio. So for example, let me see the next slide first. So look at this guy now. You might not really understand what they are trying to do here, but I will explain with a particular example. Oh my God. So let's say, for example, I'm going to initialize a particular value, which is my counter in this case. I'm going to initialize a counter value to be so any value that you like. Okay, so for example, in this case, when I wanted to print when I wanted to print 6 to 10, I said if I greater than 5, print I for this particular for loop. We want to use this with while loop. Say I want to print 6 to 10. I can say while so first of all I will initialize I can say I is equals to 5. I'll now say while I is less than 10. So I'll put this condition in a bracket. While I is less than or equals to 10, because I want to print 6 to 10. While I is less than equals to 10, what do I want it to do? Print I. Now, because first of all, I already initialized I to be 5 here. I already initialized I to be 5 here. I'm not saying that while I is less or equal to 10, do this particular operation. Now, if you should print I, it means that it's going to check I is 5. Is I less or equal to 10? It's going to print 5. Then it comes back to this place and check again. Is 5 less or equal to 10? Yes, it means 5. If I should just run this command like this, this will continue to print 5 till Jesus comes. So how do I intend to stop the loop? Because I just need it to print 5 to what? To 6 to 10. I don't want it to print 5. I want it to print 6 to 10. So I will initialize I to be 6. So how do I intend to make this guy stop? It means I will have to make I to increase for each iteration. So I will say I is equals to I plus 1. I'll make I to increase by 1. So first of all, so after I initialize I to be 6, it checks this guy. Is I less than equals to 10? Yes. It prints I. And what's the value of I at first? 6. It's going to print 6. Then it comes to this line. You now say I is equals to 6 plus 1 because my I is 6 in this case. So I is going to be 7 at this point. Then it comes here to this while loop. Is 7 less or equals to 10? Yes. It prints 7. Then it comes here. It adds 1 to 7 again. I has become 8. And it comes here and check. Is 8 less or equals to 10? Yes. It is true. Then it prints what? I, which is 8 in that instance. Then it comes here, it adds 1 to 8 again. That's 9. It comes here, checks. Is 9 less or equals to 10? Yes. It prints what? The value of my I, which is 9 in that instance. And it adds 1 to I in this case, which makes it 10. Then it comes to the while loop again. Is 10 less or equals to 10? Yes, it is true. Then what? It prints I to what? 10. Then it adds what? 1 to 10 in this place, which makes it what? 11. And now comes here. Is I less or equals? Is 11 less or equals to 10? No, it is not true. Then it stops. So it won't perform anything again. Then at that point, it's going to stop. So it means I will have 6 to 10 to be printed in this while loop. Do you understand?
Yes, Manuel.
Okay. So let me run this now so that you can see. So I'll highlight it up to the place I initialize I to be 6. So as you can see here, it printed 6, 7, 8, 9, and 10. So that's an instance of the while loop. The while loop. You can write it different kind of instance, but depending on what you want to use it to do, what you want to use to do. Okay. Let me go to my slide again. Okay, so in this case, let me try to explain what we are trying to do here. So you see, they created an empty variable, temp and temp1. This ls command is going to show that, okay, I want to check what are the objects that have been created in the workspace. So surface object name, which are initially empty here. So they created another vector, empty vector j. They now say, okay, name. They created an object and call it temp. Temp. An object name, then I assign a string to it called temp. Then I say where while exists, while then in the condition they said exists nm equal to paste name comma j comma separator is equal to an empty quote. So it means I want to append name, which is what temp here, and j. Our j is empty at that particular time, right? So our j is empty at that particular time. So I'm going to append name, which is temp with j. So where exists this guy? Now it checks this guy actually exists at this particular time, because if I say nm is temp and j is empty, so it means nm is going to be temp, and temp already existed because I've already called it here to be null. So that object already existed. So it comes here. It comes to this next operation and says, okay, if else, this is like like if else condition of a thing. So if else, so they are together. So if you check this statement, is dot null J, you check is J null. If J is null, then assign J to be what? To be 1. Else assign J to be what? J plus 1. But in this case, J is null because at that particular time J is still null because we have already initialized J to be null. Then what does it do? It's going to say J is equals to 1. So J is going to take 1 in this case. So J will be 1 in this place. Then it comes back to this condition again. While exists, you check exists, name is going to be paste name. My name is TEMP. Append it with what? J. My J is 1 now. So it means my NM is going to be TEMP1. Does TEMP1 exist? Yes, we have already created it here, which is null. Then it comes to this place, this if else condition to perform this operation again. Is dot null J. J is not null in this case because J is 1 already. So it does not come to this one. It does not do this condition. Then it does the else condition. And what does the else condition do? J is what? J plus 1. That would be what? 1 plus 1 because our J is 1 in that instance. So what's 1 plus 1? 2. So our J is 2 in this case. And it comes to this while condition again. While exists NM equals to paste name comma J. Name is what? TEMP. J is now 2. That's TEMP2. TEMP2 does not exist before because as you can see here, they said when they ran the ls command, say the guy is all the object here is empty. You already created TEMP and TEMP1 and J to be null. So TEMP2 in this case does not exist in the workspace. So since TEMP2 does not exist in the workspace, then it's not going to perform this operation again. Then it's going to stop. So that's what this guy is saying in this place. Okay, moving on to the next slide. As a consider the following R command: x is 4, y is 2, z is x minus y. Then they call z. So z is going to be, that's 4 minus 2, which is 2. So don't forget that you separated the command bits a semicolon. Okay. Talking about R Hadoop is just having to integrate R with the Hadoop ecosystem and make it to be able to use the Hadoop capability like the HDFS, the HBase, and the MapReduce. So one of the packages that exist in Hadoop is the RHBase, RMR, RDFS. I think those are the 3 packages that, as you can see here already. So Hadoop consists of the following package: RMR2, RDFS, RHBase. RMR2 makes it to use the MapReduce functionality in Hadoop. RDFS makes it to use the storage in the Hadoop, which is HDFS, and RHBase makes it to be able to use the HBase tables in the Hadoop ecosystem. So Hadoop is a combination of client-side R and the Hadoop framework. So an open source collection generated by Revolution Analytics, that the one that actually started it, to allow users to integrate the functionalities of R with Hadoop. So the essence is that to onboarding analysts with having to write MapReduce programs from scratch using Java, because not all analysts can actually use, even most analysts cannot write Java programs. So it actually onboarding them to having to write MapReduce programs using Java. So you can just write your own MapReduce program using the R, the R Hadoop, the R Hadoop. So you can write your own MapReduce program using R. So the core functions include the Adobe distributed file system and the map reduce function. Adobe distributed file system, which is the storage for the Adobe, and map reduce function for carrying out computation tasks. You already know about map reduce by now. So moving to the next slide. So installing Adobe. To install Adobe, first of all, you need to install some certain packages. So to install the R packages, the R-based package has to be installed on the system first. All this information, I think you have it in your book. You have it in your book. That will be in session 3, module 2, module 3, session 3, yeah. Let's say module 3, session 3, yeah, module 3, session 3. So there are some certain packages you have to install. You should have it listed in your book already. I don't know whether they listed it here. I think they would. So here they are saying creating user-defined function using the, after you have installed your R Adobe, you'll be able to write your own map reduce program. Here they were trying to write your own map reduce program. So you have a word count. First of all, I think they would have created the map and reduce function before you now write this word count function. Create this word count function. Is not well listed in this on this slide. So we already know what a map, both map and the reduce function takes key value pairs. So you have the key, you have the value. They've already created the map and reduce function before they started this. Let me see the next slide. Okay, I think this is the map. This is the reduce function. So the map reduce function is called by using the following commands. Then after you have written your map reduce, your map function, then reduce function. Then if you want to, there's a map reduce command in the R Adobe. It's a map reduce. Then input. That's what you want to take as your input. Input is output is equals to output format. Input format is text. Then map is going to wc.map. That's the map function you have created before. If you say reduce is equals to wc.reduce, this one can be any name you give it. System this is the function you should use for your reduce. Then combine is equals to t, which is combine is equals to true. So then this is going to perform this particular map reduce program on this particular input, then store the results into this output. Yeah. Say Alex, the developer in ABC Data Analytics, needs to carry out big computations on a data set. Which are the following functions will select to perform this task? That's the map reduce function. Yeah. So that brings us to the end of this session. We are really lagging behind, I must say. So this is just the summary of what we talked about in this session. Talk about the vector matrices, data frames, indexing vector matrices. They didn't really talk about data frames in this. I don't know whether they skip it, but the way you index in matrices is the same way you index in data frames. So there is not such difference. There's no difference. So also, yeah, we talked about lists. I didn't really talk about indexing with list, but let me show you. Sorry, let me show you here. I won't be able to cover everything, as you all know. So it means you have to practice. So let me just quickly do something here. So I'm going to create. So let me create a vector. Say 1 to 10. I want to create a matrix. I'll call it matrix. I'll use the matrix to create it. So say 1 to 20. From this vector 1 to 20, number of rows I want it to be 5. Number of columns I want it to be 4. You can decide to explicitly write it. N row is equal to 5. N col is equal to 4. But I'm following the particular order, so the system understands that I'm saying that number of rows is 5, number of columns is 4, and I want to say, okay, by row is 4 by default, but you can set it to be true. You want to give it a name, dim names, that you want to give the column and the row a name, then you can use dim names is equals to, this is in a list. So the first guy is going to be your row names, then the second guy is going to be your column names. That would be, I can say my row name, since my number of rows is 5, I want to make it just letter A to E. So letters, I'll use the letters vector to create this guy. So I want it to be the first 5 letters in uppercase, comma. My column name should be, since it's going to be 4 columns, so I want it to be the last 4 letters. The last 4 letters, since we have 26 alphabets, that will be 23 to 26. 23 to 26. That's the last 4 letters in the alphabet. Yeah. So let me create, I've created that. So I also have iris. Iris is a data frame, so I think that's fine. So I want to create a list with these 3. So I'll say my list is equals to, I use the list function to create the list. So I will say VEC, or my vec is equals to vec. That is, my vec is equals to vec is that I'm giving it a name. If you don't give it a name, it's just going to give it a default name, which is going to be 1. So I'm saying my vec, this is the name I'm giving this vector, which I've created to be 1 to 10. Then I now say my matrix. Let me call it my vector. Then I say my matrix is equals to matrix. Don't forget, all of these are a single element in a list. This is an element in a list. Should I call it an element? Okay, an element in a list. This is another element again. Then I will now say my data frame. So I'll say my df is equals to iris. So a list can contain anything, be it vector, be it anything. So if I should run this guy now, okay, let me call my list for you to see my list. As you can see here, I have this last guy is my data frame, which is iris, and the second guy, I have issue with this guy. Oh, sorry, I called it matrix. Sorry. Hey, sorry. It's supposed to be matx. That's what I called it, matx. Sorry. So let me call it again. So this is my iris data set. Then this is my matrix that I created, wxyz, ab to e. This is my matrix that I created, and this is my vector. So if you want to index it, like suppose I want to call this first guy, which is my vector, I can call it by the name, using the names, because I've given it a name. Sometimes it might not give it a name. So if I want, since I know the name, I can call it, say, my list of my vector. So it means I want to call my vector that is inside my list. So this is going to give me just the vector inside it. So let's say I want to call the first 5 elements in this my vector. I think I should be able to do this with this guy. I'm not sure, but I should be able to do this. So you can see I call it with the first 5 elements in my vector. But sometimes you might not have the name. You know, I purposely did this so that I can give it a name. Sometimes if you didn't do this, it's not going to be in this form. You cannot be able to call this with this ampersand sign, because it's going to give it a default name. Instead of my vector, since it's the first guy here, it's going to have 1 as the name. Like it's just going to be in form of a whole number. So suppose I don't know the name, it doesn't have a name. The way I'm going to call it is this. I'm going to use a double square bracket. So double square bracket 1. This is going to call the first element in my list, which is my vector, as you can see. So now, if I want to now call the first 5, so after this double square bracket, I'll put square brackets 1, 2, 5. So that is going to give me the first 5 elements in my vector, as you can see here. So that's how to index in the list. You guys need a lot of practice, so it's very important. So let me move on. I think that's fine. I hope you understand. Hello?
Yes, Emmanuel. I understand.
Okay. So graphical analysis in R. So here, let me start from here. This, what would you want to talk about here? So today's objective in graphical analysis in R, we're going to talk about how to depict graphical analysis for single or multiple variables in R. So also implement graphical plots for multiple comparisons and depict special graphical plots using inbuilt R functions. Also implement the steps to save graphics to files using R. Let me minimize this. So I hope this thing is not charging. It's not charging again. It is well. Okay. Okay, so let's continue. Analysis of graphs can provide many insights into the properties of a plotted data set. Sometimes you might have to plot maybe scatter plots, histogram, bar plots, pie charts to see the representations of data points in a particular data set. So graphs are useful for non-numeric data such as colors, flavors, brand names, and more, where numerical measures are difficult or impossible to compute. Producing high-quality graphics is one of the main reasons for doing statistical computing. So we have various types of plots. You have the plots with single variables, plots with multiple variables, and also special plots. So let's see how this goes. So plots for single variables, you have histograms, index plots, time series plots, pie chart. So say, for example, I want to see the distribution of sales. Let's see the distribution of sales for a particular period of time. I can plot this in using an histogram. I can plot this using an histogram for a particular period of time. So I can group it into bins if need be. Then I can, okay, maybe I want to see the closing price for a particular currency, maybe for a particular period of maybe 3 years, exchange rate of a particular currency. Then you can use the time series plots to see this guy. So you know it fluctuates over time. It's something that's real time. It changes with time, split seconds. So you can use the time series plot for this case. And if you want to see distribution of certain categories of solutions of a particular maybe categorical variables, you can use pie chart in this case. Probably want to see, okay, which particular products which particular product sells, or how a particular product sells. So you have 4 different products. You want to see, okay, which one, what's the rate of purchase of those products, depending. So you can do a pie chart so that you can see, okay, the sales more than this particular product, and this one maybe sells as twice as this particular product. You can see these distributions in a pie chart in that case scenario. So let's see the next slide. You can use the is function to plot histograms. As you can see here, plots, you can use this plot also to plot histogram, depending if you put the type parameter. In this case, plot.ts is used to plot time series plots. Sometimes you can use ts.plots. Then you can use pie function to plot a pie chart. So here you have histograms of different kinds. As you can see here, histograms can be used to display the mode, spread, symmetry of a set of data. Mode is that, okay, which one occurs most times? Okay, how is it spread? How is the data points spread over a particular period of time? In this symmetry, the R function is used to plot histograms. Sometimes histograms can be tricky because what you see depends on the subjective judgment of where exactly to put the bin margins. So sometimes you might have to specify that yourself, X limits, Y limits, stuff like that, because automatically I'll just plot it, those histogram based on your minimum and maximum value, but some data points will be hidden. Some data points will be hidden due to those decision that how does automatically by itself, but you have to specify some parameters so that you'll be able to see the distribution even for those little values that are not being shown automatically by R. But let's to the next step. So you have to also go through your books, because all of this information are not really on this slide, so you have to also follow with your material. So while using the is function, the number of bars or widths of bars cannot be specified. For small integer data, the best plan is to have one bin for each value, because histograms and percentages that are much more challenging than explanatory variables. So you can use the cut function to break your data points into bins. I think that will be more flexible in this case to plot your histograms. I'll use an illustration in that case. So for example, let me go to my R here. So let's say iris data sets now. As you can see, if I want to plot this histogram of this guy, maybe this petal dot width, or let's say sepal dot length. So I say is, if I say is of iris and sepal dot length, and I have this guy. So if you look at my x-axis, you can see that it starts from 4, and this it ends at 8 here. So sometimes I want to see the minimum and the maximum value in this particular.
Excuse this the column you just used one column to plot this graph.
Yes, no.
And it assigned frequency on its own.
Yes, of course.
Okay. So what if I have 2 values I want to plot on this histogram?
You cannot plot 2 values. You cannot plot 2 columns. in fact, it's only one column you can plot. It's called a single variable. It's not, you can't plot multiple variables for histograms. You can only do that with scatter plots. You understand?
Okay.
So if we look at this x value, this x axis, you can see that it starts from 4 and it ends at 8. So I automatically identifies that. But if I want to check the range, sometimes some information might be hidden. If you look at the range here, the minimum here is 4.3, the maximum is 7.9. So this can be so fine, but I might say, okay, I don't want it to be like this. Maybe I want my x limits to be equals to start from 0, and maybe this one should get up to maybe 8 is fine, or 9. Let me just extend it to 9 and plot it again. You can see that it's kind of different from what I had before. So maybe 0 is too much. I can just say, okay, I want it to start from 3.5 to 8.5. You can see that even 9 doesn't even matter. So let me say 3.5 to 9.5 at least, or maybe 8.5. But sometimes you might say, okay, I want I want to break my columns into bins. What do I mean? So I want some set of points to fall in a particular category. So I have 4.3 as my minimum value. I have 7.9, 4.9 in a particular. So 4.3 as the minimum value, 7.9 to be the maximum value. So but I want to break this guy into bins, into buckets. So let me put it that way. So let me say I want to start from 4 to 8. So let's say the minimum, I want to pick from 4 to 8. So values from 4 to 4.5 should fall in a particular bucket. Values for 4.6 to say 5.0 should fall in a particular bucket, and stuff like that. So in that way, I'll be able to see the distribution very, very well instead of all of this. So I'll know that from this place, this first bar accounts for a certain value. This second bar accounts for a certain value. In that way, I'll be able to get the distribution properly. So in that case, I can use the cut function. Oh, this place is so cold. I can use the plot function, the cut function. So I'll say cut iris ampersand, sorry, separ dot length using sequence from 4 to 8. Oh, but yeah, difference of 0.5. So 4 to 4.5, 4.5, and yeah. Okay, yeah. Let me try this. Let me see. So as you can see here, it has been separated into several buckets. So here you are seeing that I see 5 to 5.5, 4.5 to 5. This is depending on the buckets all of these data points belongs to. So all of them have been separated into several buckets based on this particular sequence. So So data point that fall from 4 to 4.5 is going to take this particular interval. Sometimes I can give it a name instead of this particular interval that's created for me. I can give it a name, but I don't. Maybe I don't want to give it a name. So instead of me to say plot this guy now, I'm going to use plot of this guy. So let me use this. Sorry, plot. So here you can say from here is 4 to 4.5. This is let's say 4.5 to 5. This is 5.5 to 5 to 5.5. This is 5.5 to 6. This 6 to 6.5. This 6.5 to 7. This 7 to 7.5. This 7.5 to 8. So I know that okay, values that fall from between 4 to 4.5 are 5. Values that fall between these buckets are maybe 20 something. You get? Do you understand? Hello, are you with me? Hello?
Hi.
Are we on the same page?
Yeah, we are.
Okay, so moving to forward. Index plots. Index plots can be used for plotting single samples. The plot function takes a single argument, which is a continuous variable, and plots values on the y-axis with the x coordinates determined by the position of the number in the vector. Blah 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 blah. So this is just index plot. It's just me. I want to plot instead of me using this guy in this case here. Instead of me using east of iris the sepal length, I got this kind of plot here. I will now say plot iris ampersand, sorry, iris ampersand sepal length. So this is an example of index plot. Oh, as you can see here, index. So you give this index, and these are the values of your these are the data points in the iris and the separate column, and these their position and stuff like that. So that this is index plot for you. Just plot a continuous values, a single continuous value using the plot function. Okay. Also, you have the time series plot. So I already explained time series plot to plot data that changes over time. So when a period of time is complete, the time series plot can be used to join the dots in an ordered set of y values. So the issues arise when 3 or missing values in the time series for some interval for which nothing is known about the behavior of the time series, blah 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 blah. So all this one are just story. So for example, I've already mentioned you want to check the closing price of a particular currency over a particular period, just like forex kind of charts. So those kind of charts are called a time series plot. Those are the kind of data that changes over time, a real-time data set. Then use a time series plot to perform the operations. Here he said, so the figure shows a time series plot plotted using the what I saying? It's a ts.plot function. You can use plot.ts any which one. So there is an inbuilt data set in R, which is a time series kind of data. Let me check the next slide whether I can Wait, they didn't. I think I should be able to figure it out. I should be able to figure it out. Let me check so that you can see what I'm talking about. So you have inbuilt. If to check the inbuilt data setting, I'll use the data function. So data into bracket. This is going to give you the drop down of inbuilt data set that you have. I think I should be able to see some data set at a time. Let me check the ones that US ACC dates, both dates, source plotted here. Okay, I think let me go up. Okay, UK driver date. I think, yeah, this is the time series data. So let me open this. So let me check the head of it. Head of UK drivers dates. Yeah, UK drivers. Yeah. So, okay, this is a time series data. So I'll now say plot. Yeah. Let me call it so that you can see it in full.
Emmanuel, sorry, my network is.
Hello, can you hear me?
I can hear you, but I think my network is slow, so I'm not really seeing what you're sharing.
Can you see it now? But you can see my screen.
I can see your screen, but not what you're sharing. Maybe my network will come up. I think it's my own network.
Are you seeing the app studio?
Okay, I can see it now.
Can you see the data that I'm opening? UK driver dates.
Yes.
Okay. So this is the time series data set. As you can see, it's over a period of 1969 from January to December, 1969 to 1984. So it's a month. This one is monthly. So this data set of January 1969, February 1969, stuff like that. So it's kind of a pivot kind of data set, but that's how a time series data looks in R. So if I want to plot, I don't, since it's already a time series data, I can use the plot function. Automatically, this is going to understand this is a time series data set. So you're going to look at the time series plot. As you can see, this is the plot. If I use plot.ts, it's still the same result I will get. This is a time series plot. As you can see, the way it is from 1969 to 1984. So if I use plot.ts, it's still the same result you're going to get. Plots.ts UK drivers. As you can see, we still have the same thing. All right. Can you see? Could you see the plots? You could see the plot, right? Hello, are you with me?
Yes.
Okay. Okay, so moving forward, pie charts. You can use the pie function to create a pie chart. So here, as you can see, This is a pie chart showing the distribution of oil, gas, coal, oil shales, methyl clutterate, and stuff like that. So use the pie function to plot a pie chart. Let me see. I think I should be able to demonstrate it using the what is it called? The iris data set. So, but before, let me just move on first. I'll come and demonstrate that later. You have the strip chart function. This one is, as you can see, it's kind of plotting the frequency. These are discrete variables. So this is usually used for discrete variables. For sample size that are too small, for example, observation less than 30, and alternative plotting method is to use the strip chart function. The objective of using strip chart is to look carefully at the location of individual values within the small samples. The strip chart plot can be specified by a model formula, y against the factor, and strips can be specified to run vertically rather than horizontally. So this is more like plotting the discrete value. As you can see, it's also used to plot for small samples. So for if you go over your material here, you're going to see the essence of using the strip chart function also. And plots with two variables, that's where we talk about scatter plot. But before we go into that, let me just illustrate the pie chart using the pie function. So here, so let me call the head of iris example. So if you want to see the distribution of species, and so first of all, let me check unique. I want to check the unique data points you have for species, for examples. Iris ampersand species. So I want to check the distribution you have for setosa, versicolor, and virginica. So probably I want to say, okay, how many of these guys do you have in this particular column? So I can say pi of iris ampersand species. Oh, sorry. I want to say pi. How should I put it? Okay, so let me put it this way. So I'll say pi of table of iris ampersand species. So as you can see, you have the distribution here. So you can see that it's equally distributed. So you have like 50%. So I can't say 50%. So it's in percentage. So you have 150 data points in the iris data set. So 50 is versicolor, 50 is setosa, 50 is virginica. So let me show you the result of this table command so that you can see it properly. Oh, let me end it. So you can see 50 versicolor, 50 setosa, 50 versicolor, 50 virginica. That's why you have these quadrants to be kind of the same thing. I'll just give it the default color, and the names here automatically it just gives it as the title of these names, but you can change the name by yourself by using the parameter in the pie function anyways. So yeah, so I can say, okay, maybe yeah, depending on what you want to achieve, you can use the pie chart. So I think that's basically it. You can read more about parameters you can input into it, color, and stuff like that. So if I want to change the color, I can say col is equals to, I'll put it into combine function. Since I have 3 different categories, so I would specify 3 different colors. I'll specify 3 different colors. I can say this one is, the third category should be red, this one should be blue, and this one should be, say, orange. So as you can see here, you have the color implemented here. So just read more about it. It's not something difficult. All right. Moving forward. Yeah, moving forward. So plot with 2 variables. So the 2 types of variables used in graphical analysis are response and the experimental variables. The response is your dependent variable, while your experimental variable is your independent variable. So the response variable is represented on the y-axis, which is the independent variable, and the experimental variable on the x-axis. So the kind of plots produced depends on the nature of the explanatory variables per se. So when the explanatory variable is a continuous variable such as length or width or altitude, the appropriate plot is a scatter plot. In case where the explanatory variable is categorical, such as genotype, color, gender, the appropriate plot is either a box and whisker plot or a bar plot. So this is what we are saying in essence. This is what we are saying in essence. So let me move to the next slide. So the most frequently used plotting functions for 2 variables in R are scatter plots, bar plots, box and whisker plots. So box and whisker plot is what, again, as you can see here. See, when you have the explanatory variable to be a categorical variable. So this is scatter plots. When you have your 2 variables to be continuous, you understand? So for example, let me move on to the next slide before I go to the example. So for example, you have, so I want to plot the sepal length with the sepal width. So iris ampersand sepal length, comma, iris ampersand sepal width. Automatically, both of them are continuous variables, so it's going to be a scatter plot. As you can see here, if my response variable, my explanatory variable is a categorical variable, so that's going to give you a box and whisker plot. So for example, iris ampersand species, which is my x, this is a categorical variable, and I want to plot this with the response variable sepal.length. As you can see here, this gives you a box and whisker plot. This gives you a box and whisker plot because your explanatory variable is a categorical variable. So this is going to show you the distribution of sepal length for species Setosa and versicolor and virginica, how they are distributed. So if I want to do, I can also use bar plots in this case. Bar plots, and let me just copy this. Okay. What did I do? Wow. So let me copy this. Let me try and copy this here. Okay, I think, sorry. Iris ampersand sepal and then iris ampersand species. He said N is not allowed in external narration, blah 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 blah. Okay, let's put x limit to be equals to 3,8. This is not necessary. This is not what I wanted to plot though. But if I want to use this guy, it means using it like this doesn't make any sense, because the way I want to plot it is like probably I want to use a histogram, then I'll see the distribution of sectosa, blah blah blah. Then I can say I can use the apply function. For example, let me just copy this guy. Should I? No. So not this guy. So for example, the way you can use this that can make it meaningful for you is to plot. Say, okay, what is the average sepal length for each species? Then you can use the apply function, then use the bar plot on it, or the histogram per se. So that was going to show you the distribution of bar plot. So that's going to show you the distribution of it's going to show you the average sepal length for each species in the iris data set. Because of time, I won't have to go over this. So you can go over your material, practice these functions and learn how to use them. So let me go on to the next slide. Interaction plots. These are useful when the response to one factor depends upon the level of another factor. They are a particularly effective graphical means of interpreting the result of factorial experiments. Factorial experiment refers to an experiment that has a design containing. So these are useful when the response to one factor depends upon the level of another factor. Let's see an instance of that. Limited control. Okay. Let's see an instance of that here. Did they? No. Let me check the manual. So let me check the manual for instance, whether I can have this here. Graphical analysis. Interaction plots. I don't think this is inside your. Okay, so that's a challenge for us. So you can read more about interaction plots. I can't find inside your manual. So you also have special plots, special kind of plots. So all these special plots, they are more of like a user-defined plots. What do I mean by that? It's like you are trying to build a special plot using some certain functions. So it's not that it's inbuilt that you just did and just give you the plot. For example, the bubble plot, as you can see here. So if you look inside your manual, you see the way they created the plot. You have to use some functions to make the plots come into existence. So it's not as straightforward as some other plots that you have seen, like bar plots, histograms, pie charts, and stuff like that. So, apart from various kinds of graphical plots discussed, I'll support the following special plots: design plots, bubble plots, plots with many identical values. Okay, so you have okay, what's the first plot? They talk about design plots. So design plots can be used to visualize effect sizes in design experiments. So design plots can be plotted using the plots.design function, which can be used as plot.design growth rate, your y-axis, model it against water, detergent, and DAFNA. The figure shows a design plot plotted in R using this plot.design function. So this is the result of what you have. You have the growth rate plotted against water, detergent, and DAFNA, as you can see here. So yeah, so you have three factors: water, detergent, and DAFNA. You can see the interaction of these three categories with growth rates in that regard. So also we have bubble plots. Sometimes bubble plots is more or less used when you want to see the how can I put it, number of occurrence of a particular value. So let's say in kind of a word count. So you want to see the number of occurrence a particular word appears in a particular sentence or a particular text. So the words that occurs most, you have a bigger circle. So you'll be able to see clearly that, okay, this particular word occurs most, just like histogram, but in this case, you have the plots in forms of circles, bubbles in this case. So give me a minute. So as I was saying, bubble plot is useful for illustrating variation in the third phase across different locations in XR plane. The illustration I just gave you is just how you can understand how bubble plot is being used. But let's see the next type. As plot with many identical. This is also another kind of plot. So more of like, wow. So more of like you are trying to plot. So sometimes two or more points with count data fall in exactly the same location. Fall in exactly the same location in the scatter plot. The repeated values of y are hidden, one buried beneath the other. Okay. Okay. So let me check. Hold on. Bubble plots and okay. So this is used to, in this case, this is used to plot a particular variable that some data points are identical to each other. So you'll be able to identify, just like you want to cluster some points together in such a way that, okay, maybe data points that are close to the left bottom, they have the particular pattern, then the design is going to be similar, then data points in a particular position, a particular location is going to have a kind of separate design too. So you can actually see the difference between those data points. So you can use this sunflower plot function to achieve that in that case. So I think this should, okay. So saving graphics to file. So how do you save all of this? Probably you plotted your visualization, stuff like that, and you want to save it. You can save it as a PDF file, you can save it as a JPG, like an image. So you can use, so for example, you read a particular data set, folio.txt. Let's see the next slide, and this one is not necessary. Let me go back. So you have plotted this. So let me go back to my app, and you want to save it. So see this guy, see this particular plot now that is in this my right bottom corner. Hello, can you see my Arc Studio?
Not yet.
Let me know if you can see it. How about now? Can you see it now? So if you want to,
yeah, I can.
So if you want to save this guy, you can say export, then save as image or save as PDF, or copy to clipboard. That's if you want to copy and paste in a particular, say Word or something, you can copy them, right click and go and paste there, or you can just save directly as image or save as PDF. So also it's not only on this particular console or this particular Windows that you can plot your graph. You can also use Windows function. Say Windows function. Say Windows and put a particular frame, so like the width and the height respectively. So if you want this pops up. So anything you are plotting, you can see it here. So let's say if I want to do this bar plot again now, it's not going to show here. So it's going to show on that frame. So if I should go to my, so as you can see here, you can see it. This is the plot now. So if you want to save this guy, you can save file, then save. These are the different formats of which you can save it as JPEG, PNG, PDF, and stuff like that. So that's it about saving your graphics. All right. Now here we talk about selecting an appropriate graph. So you have line graph, you have pie charts, you have bar graph, area graph, and stuff like that. So the line graph is used to display the over the time period It is generally used to keep track of record for both long and period and short, blah blah blah. So if you want to do that, sometimes if you want to use the line graph, you can put it as a parameter in the plot function. So the area graph is also used to track the changes over the specific time period for one or more groups related to a similar category. You have the XY plots, like your scatter plot and the likes. Yeah, and this gives us a summary. So as I was saying about all of these graphs, so for example, let me go to my RStudio. I was trying to plot this guy. So I plotted this guy to have this. So if I want to make it like a line graph, I can put type here, comma, I can put time type, say type. If you look at this guy now, if you look at these details here, type is equals to